Okay, so this time we're going to run another surge test at 2.2 kV, but this time I've turned on the pulse-to-pulse EAR function, which we've just spoken about. So let's see how that changes the test. So this software here is the pulse-to-pulse software. So each waveform, as the voltage is being increased by 50 volt steps, or 70 volt steps in this case, we have each pulse has a waveform, and we're comparing the difference between the waveforms or the pulses as that voltage is being increased in equal steps. So what we're looking for are spikes in the pulse-to-pulse graph that would indicate a sudden large change from one pulse to the other. In other words, a large difference between the waveforms from those two pulses. And so far we're not seeing anything. We've got a very smooth graph indicating that the difference between the pulses is very small. Okay, so now phase 3. Phase 3 actually has weak insulation. So when we reach somewhere in the region of 1800 volts, you should see a change in the pulse graph. There we go. So again, the test has passed. Okay, so line to line 303 still. But when we look at the pulse-to-pulse graph, suddenly now we see a fairly significant spike, which shouldn't be there, and that indicates weak insulation. But it didn't pass through our 10% tolerance line, so the test continued, and therefore it's a pass. And obviously we could reduce that tolerance down to a lower value once we understand where the first pulse will be. So in this case it's 5, so we could probably set that to 6. And that would still have passed, but we can see very clearly there's a problem.